Turn to page R10 and let's look at Zener diodes. Everybody's always interested in what the hell this is, a Zener diode, because it does have such a strange name, in this case named after Clyde Zener. No, not really. I don't know who it's named after, actually. Bruce Zener? Okay. Anyway, a Zener diode looks, schematic-wise, looks like a regular diode, like this, and it has a cathode, and it has an anode, just like before. But to show you that it's a Zener, it has these little angular bits that kind of form like a stylized Z for Zener. Zener diode. Now, if you look at the chart, look down the far left-hand column here, the far left-hand column where it says nominal Zener voltage. And if you look at these voltages, they're nothing like the kind of voltages that we've seen so far. I mean, so far, when we've been looking at voltages for diodes, for instance, we had 50-volt diodes, and 100-volt diodes, and 400-volt diodes. And when you look at these voltages, they're real strange. They're like 6.8 and 8.2, 9.1, 10, 11, 12, 14. The Zener diode voltage means something completely different than the voltage rating of a regular diode. In fact, the Zener diode works in a completely different way. In fact, the only reason it's called a diode is that it has two leads. Diode, two leads. Other than that, it actually works completely different. It's a whole different animal. Here's the deal. Every Zener diode has its own voltage rating. Let's say, for instance, that we have a 12-volt Zener diode. Here's what this means. As long as the voltage on the cathode is less than 12 volts, or I guess I probably should say 12 volts or less, the Zener does block just like a regular diode does. Now actually the Zener diode would always conduct in that direction, the same way the arrow points, but we never use it that way. Current is never allowed to go through the Zener diode in the forward direction because it wouldn't do anything. It just doesn't do anything. As long as the voltage on the cathode is 12 volts or less, the Zener does not conduct. It blocks it just like a regular diode does. But if I exceed the Zener voltage, the Zener diode will start to conduct. And this is the only part that conducts opposite the direction that the arrow points. It's like I before E except after C. It's the exception to the rule. Tough bananas, that's the way it is. It's the only part that does this. And here's what it does. I've got 2 volts on the cathode, does not conduct. 3, 4, 5, doesn't conduct. 8, 9, 10, doesn't conduct, blocks at 12. If I exceed the Zener voltage, let's say I put 13 volts here on the cathode, the Zener diode does start to conduct. But it doesn't just snap on. It doesn't turn on instantly. The Zener diode's a real selfish little bastard. If you can give human attributes to a component, this is the most selfish little bastard you'd ever want to meet, because here's what it does. It says, okay, you put 13 volts on my cathode, I'll start to conduct, but I'm going to keep the first 12 volts for myself. I'm a 12-volt Zener diode, damn it, I want the first 12 volts. Anything that's left, you can have out my anode over here, and it'll put 1 volt out over there, out the anode. In other words, it says, look, I'm a 12-volt Zener. I want to keep the voltage across myself at 12 volts at all times. Zener diodes are sometimes also known as regulator diodes, because that's how we use them. The Zener diode will try to keep a fixed voltage across itself at all times. Anything that's left over, it'll put out the other side. So, for instance, if I have the same 12-volt Zener, and I put, let's make the math easy, I put 22 volts on the cathode, keep the first 12 for itself, I'll get 10 volts out the other side. Now, there's a couple of different places where we might want to use a Zener diode like this. For instance, we might have a circuit that has a 100-volt power supply in it. Let's say there's some circuit that needs 100 volts, and there's a 100-volt power supply. But there's another circuit in the same unit, whatever it is, that needs only 20 volts to operate. instead of making a separate 20-volt power supply, they might use an 80-volt Zener diode. Run that 100 volts through it, and what would come out the other end is 20 volts. And then that would go to the other circuit that uses 20 volts. In other words, it would cut down a known amount of voltage. That's one way we can use it. That's not the most common way, though. The most common way to use a Zener diode is like this. They will ground the anode of the Zener diode. Let's say it's a 12-volt Zener diode. The voltage right here will be kept at exactly 12 volts no matter what. In other words, there's some kind of a power source coming in here. And I'm intentionally being kind of nebulous about this because it doesn't matter, where this comes from to explain what this part does. Let's say we've got this power source. In fact, let's use an automobile as an example. Most cars have like a voltage regulator circuit in them. The deal is when your car is at idle, let's say, the alternator or generator in your car is putting out 12 volts, perfectly normal. But when you start stepping on the gas, you start going faster, the faster you go, the voltage would start to rise. We don't want the voltage to be 18 volts going into your 12-volt battery, so they have a voltage regulator circuit that regulates it. This does essentially the same thing. As long as the voltage here is less than 12 volts, this doesn't conduct. But if this starts to go up above 12 volts, the Zener does start to conduct and drags any extra voltage to ground, basically. There will be a resistor in here that I haven't discussed with you. The extra voltage will be dropped across that resistor. The voltage right here will stay at exactly 12 volts no matter what. We use these as voltage references. And I'll point it out to you later on in a couple of other circuits where we use the Zener diode as a voltage reference to keep the voltage there at exactly a certain point. Here's a cool way to think of the Zener diode. Imagine a water tank. I have a pen full of water here. There's water. And let's say here's a hole in the water tank, a spigot with a pressure gauge. There's the pressure gauge. Obviously, the more water I have in the tank, the higher that pressure will be, correct? As the water goes up, there's going to be more and more pressure. I've got a hole here in the side of the tank. I add more water to it, the pressure goes up. Add more water to it, pressure goes up. At this point, if I add any more water to it, I can't get the pressure to go up any higher, can I? Because if I add extra water to it, it's just going to flow out the hole and land on the ground, right? The pressure is fixed. Same thing here. I've got a hole here, 12 volts. Put in 1 volt, 2 volt, 3 volts, 4 volts, 5 volts. It continues to build up the pressure. When I get to 12 volts, if I try to put any more voltage on this thing, the extra current, the extra voltage is going to go through the Zener diode to ground. It's going to come out and land on the ground. Same thing. Yeah?
So is that safety feature unlimited voltage? Good for unlimited voltage, or is it?
It would be, yes, it would be, depending on the size of this resistor. There's always a resistor here, and I'm getting more advanced, and I don't want to, called a voltage dropping resistor. The extra voltage is actually dropped across this resistor, and it gets hot as shit. It gets really, really hot. Don't worry about it. The reason why I'm telling you not to worry about it, I'm not copping out here, is that for the most part, Zener diodes will test just like regular diodes. When you have it looks like a regular diode too. You don't have one in front of you. It looks like a regular diode. There's nothing unusual about the way it looks. When you have a Zener diode failure, it will check, when you have a good Zener, it will check like a normal diode, open one way and a junction drop the other. When it fails, it will probably short circuit just like a regular diode does. However, there's a however for you. Occasionally, Zener diodes do a really weird thing. Occasionally, when a Zener diode fails, it will lower its Zener voltage, or it'll change its Zener voltage, and it usually lowers it. Turn in your blue book to page, I think it's 17 or 18, let me see. No, I'm full of it, wait a minute. I'll tell you, page 32, oh, I was really close. Page 32. On page 32, this is the Williams high voltage power supply. This is the power supply that powers the score displays in a Williams pinball. The score displays in a pinball are not LEDs. A lot of people think they are, but they're not. They're neon gas discharge display tubes. They take high voltage. They take 200 volts to operate. To get that 200 volts, they actually make two different power supplies. One is plus 100 volts. The other one is minus 100 volts. The difference, of course, between plus 100 and minus 100 is 200 volts, and that's where it gets its 200 volts. Well, what we have here are a pair of voltage regulator circuits, and we're going to look at these in great detail this afternoon. But what I want you to see is this. Look at the schematic diagram. Find this transistor Q1, right up here on the top, Q1. Notice the output voltage, 102.4 volts. Notice the base voltage, 103 volts. Remember, the base is 0.7 different than the emitter. Remember that? Okay, in this case, 0.6. Remember, 0.7 is an average reading, so in this case it's really 0.6. This Zener diode is a 100-volt Zener diode. It's a 100-volt Zener diode, and the tolerance is plus or minus 10%. Really, so it could be anything up to 110 volts. And here it's actually pegging this at 103 volts. This Zener diode is responsible for keeping the base voltage at exactly 103 volts so that the output stays at exactly 102.4 volts. In other words, this is a regulator diode. This diode is keeping the base voltage absolutely constant so that no matter what happens here on the input voltage, as it can rise up depending on what your AC power is doing, the output voltage stays perfectly constant because the base is kept at a constant voltage by that Zener diode. Well, here's the deal. The Zener diode can mysteriously change its Zener voltage sometimes, and what it does is it drops. I've never seen it go up. It's always dropped. Here's what happens. You get to the game, in this particular case, and the score displays are not working at all. The game coins up, plays, makes all the game sounds, but just no scores. You measure the power supply voltage. We'll do this on Saturday, and you find, let's say, the minus 100 is perfect. The plus 100 is only 40 volts. Oh, well, that explains why the scores aren't working. You need 100 volts. It's only 40. And this is what happened to me. So I say, well, I've got a regulator problem. It's got to be one of those transistors or Zener diodes in there, and I check them all with the power off, as you should do. They all check perfectly okay. Next step, turn the voltage on, turn the power on, and carefully check the voltage across the Zener diode. Put 1 meter lead on one side of the Zener, the other on the other side, measure the voltage across it. If it's a 100-volt Zener, it should have 100 volts across it. In this case, it only had 40 volts across it. The Zener was bad. I changed it, and that's all there was to it. I suggest that you read through this article tonight. I demand that you read through this article tonight. Anyway, but the point I'm making here is this, that in a Zener diode, most of first of all, they're not a real common failure except for this circuit. It is very common failure in this circuit. When you think you have a Zener diode failure, check it with the power off first. If it appears to check good, you will have to turn the power on, simply measure the voltage across it. Whatever the rating of the Zener is supposed to be, that's how much voltage you should read across it. The Zener diode, if the voltage rating is not listed on the schematic, it is sometimes, but it's not always, you get the part number off the Zener, like 1N4764, whatever this part number is. Well, I don't know. And you would look it up in your ECG book. Your ECG book tells you how many volts the Zener is supposed to be. Big advantage, because without the ECG book, you might not be able to figure out what the voltage is supposed to be. So Zener diodes. Now, when you substitute a Zener diode, obviously you cannot change the Zener voltage. I mean, when you look at those voltages, they're very specific, aren't they? You know, 9.1, 8.2, 6.8 is a very common one. You cannot go up in voltage in a Zener diode. You have to keep that exactly the same. But there are two specifications for Zener diodes. If you look back on page R, whatever we were on there, for Zener diodes. R10, correcto. Zener diodes do have two specifications. One is the voltage rating. You can't change that. That's got to be the same. But the other specification is the same as it is for resistors. You see along the top line, the dissipation in watts, also known as the wattage. People just say it's the wattage. And you can go up in wattage. In fact, I really recommend it. If you have a bad Zener diode in something, and it is a half-watt Zener, which would be listed probably as a 500 milliwatt, 500 thousandths of a watt. A milliwatt is a thousandth of a watt. 500 milliwatts would be a half a watt, wouldn't it? So a 500 milliwatt or 1/2 watt Zener diode, if you find one and it's bad, I suggest you go up to a 1 watt, and maybe that would keep you from having a repeat failure. This thing is